Okay, so today what we're going to look at are the sources of acids and alkalis. So essentially what that means is the types of chemical that when they dissolve will produce either an acidic solution or an alkaline solution. An alkaline solution is just the description for a solution that's got an alkali in it. So acids and alkalis, the types of chemicals, the types of sources are going to be oxides. So we're going to look at the different types of oxides that produce acid or acidic solutions and the types of oxides that will produce alkalis or alkaline solutions. And what an oxide is a compound that's made from one element plus oxygen. It's pretty easy to tell whether or not a compound is an oxide because it ends in the word oxide. So examples of these, they can be non-metals, so carbon plus oxygen goes to carbon dioxide. Or it can be a metal, something like calcium plus oxygen going to calcium oxide. So these chemicals here are oxides, and that's what we're going to be looking at in terms of which one of those are going to give acid solutions, which ones are going to give alkalis in solution. And we're going to focus first on acids. So, acids. And the general rule is that acids are non-metal oxides. Now all that means is that the chemical that's been reacted with oxygen is a non-metal. We'll quickly look at the data booklet. The data booklet, page 4. It's not easy to read, small size there, but I'm hoping that you're able to see that there's a big thicker black line that goes along here, and then there is a staircase shape here. Everything on the right hand side, so everything in this region, plus hydrogen, that is a non-metal. So these are the elements that we are thinking about. If they react with oxygen, they produce non-metal oxides. So some good examples are things like carbon, nitrogen, and sulfur. Those are good examples. And to show you these, so carbon plus oxygen, carbon dioxide. And that process, how we get carbon dioxide, that carbon dioxide, we breathe carbon dioxide out. All living things that respire produce carbon dioxide. So even plants produce some carbon dioxide, but they absorb some as well. But also burning fossil fuels produces carbon dioxide. Next one, sulfur. So sulfur plus oxygen gives us sulfur dioxide. Now sulfur dioxide, it can also be produced from burning fossil fuels. Lots of fossil fuels have a little bit of sulfur in them, but the main source of sulfur dioxide is actually in volcanoes. So the gas is given off by volcanoes. So sulfur dioxide is quite a natural non-metal oxide. Carbon dioxide is natural, but fossil fuels are what give the most carbon dioxide into the atmosphere. And the final one, nitrogen. Nitrogen plus oxygen gives us nitrogen oxide, and you can also get nitrogen dioxide. Now if I write in the chemical formulas, dioxide means CO2, means 2 oxygens. Sulfur dioxide means 2 oxygens as well. Nitrogen oxide, there's no di, so that's just 1 oxygen. And dioxide, NO2. Now sometimes nitrogen oxide, nitrogen dioxide, rather than write them both out, it gets written NOx, just as a different way, and that means both of those together. Now these are the 3, carbon dioxide, the sulfur dioxide, and the nitrogen oxides, are the 3 main non-metal oxides that you need to know about. Now, every single one of those are all gases. And because they are gases, that means they go into the air. So they and, as we said, acids are produced from non-metal oxides. So these gases that go into the air, they're going to produce acid, and they're a source of what we call acid rain. Acid rain is really bad because acid rain, well, when acid falls down from the sky, it's going to react. It can react with buildings, it can react with soil. It'll make anything that acid falls into more acidic as well. So acid rain is a big issue in rivers and lakes and in the seas. We have acidification. That's what's causing places like the Great Barrier Reef, the coral reefs, to bleach and all sort of life there to be destroyed. And the main ways in which we can stop this are by trying to stop these things from getting into the atmosphere as much as they are. Now, sulfur dioxide produced from volcanoes, we can't really do much about that. Carbon dioxide produced from humans, we can't really do much about that. And nitrogen dioxide, which can actually be produced when lightning strikes some oxygen and nitrogen in the air and makes them react, we can't do anything about that. What we can do is stop these from getting into the air from activities that we have control over. And the main thing that we can do to stop from happening is we can stop this or lower it by using less fossil fuels. Because those fossil fuels are what produce especially this, but some of this and some of this. We can also, in particular with these, we can trap these before they get into the atmosphere by putting devices on chimneys or exhaust pipes of cars. And that's especially done with the NOx, the nitrogen oxide gases. But let's go over this. Non-metal oxides, like carbon dioxide, sulfur dioxide, nitrogen dioxide, nitrogen oxide, when they dissolve, they give us acids. They're also, most of them are gases and can cause acid rain. And how we can stop acid rain is by using less fossil fuels. Now what we're going to look at now is alkalis. Now the rule for acids was that non-metal oxides produced acids, but alkalis is metal oxides. But there is a special rule as well. They have to be. They have to be soluble. And we'll look at how we can work out whether or not a metal oxide is soluble. So all metal oxides, so examples of metal oxides would be things like sodium oxide, iron oxide, potassium oxide. Now, all of those have the potential to be an alkali, but as we've said, they need to be soluble. Now what I'm going to do is we're going to look through the data booklet, firstly, so we can work out where the metals are, and then secondly, to see if we can work out whether or not a metal oxide is soluble. So we're going to show you the data booklet again. So here we have the data booklet. Now before, the non-metals were everything on this side of this line. The non-metals are everything under the line. So if you can see, at least 70% of the periodic table is metals. The most common metals that you might have heard of are in here, in the transition metals, so things like iron, chromium, titanium, silver, gold, copper, they're all in here. But also some of the reactive ones on this side, sodium, potassium, calcium, magnesium. So you just need to look at this periodic table. There's always a nice thick staircase, and everything to the left of that is a metal. Now when it comes to finding out whether or not something is soluble, what we need to do is look at this page in the data booklet. So this page in the data booklet is page 8 for the National 5 data booklet, and we're specifically looking at this table here. This table, you can see it's not so clear, but it's got a list of different metals down the side, and then it's got a list of different sort of compounds that can be made. So we've got bromides here, for example, chlorides here, and then we've got oxides here. And this is the important column, the oxide column. And there's also codes for things in the table. So we've got codes VS and S, means very soluble and soluble. And then we've got I, which means insoluble. And insoluble means it doesn't dissolve. Now, what we're looking for is metal oxides that can dissolve. Those are the ones that are going to produce alkali solutions. So, looking at the examples we have here, we have sodium oxide, iron oxide, potassium oxide. And we're going to see, is it soluble? And then we'll work out, is it alkali? So the first one was sodium. Now this list is in alphabetical order, so sodium's near the bottom. We've got sodium, and we're looking across here, and it has the letters VS, which means it's very soluble. So sodium, very soluble. That's VS on that table. Iron. So we've got iron 2 and iron 3. We haven't said, so we'll look at both of them. We go across to the oxide. For iron 2, we've got an I, which means insoluble. For iron 3, we've got an I, which means insoluble. So both of those are insoluble. And finally, potassium. So again, it's alphabetical order, so potassium's near the bottom. And potassium, actually, everything in the potassium thing is very soluble. So potassium oxide is very soluble. So now we look back at our rule. Metal oxides that are soluble are alkalis. So now we're going to be able to say, is this an alkali or not? So sodium oxide is very soluble, which means it is an alkali. Iron oxide is insoluble, so it's not alkali. And potassium oxide is very soluble, so that is alkali. Now there's one thing to be really cautious of, and that's with iron oxide. Iron oxide is not soluble and it's not an alkali. Sorry. But that doesn't mean that it's an acid or that it's neutral. It just means that it's not an alkali. It's really important that if you are insoluble, you're not an alkali, you're not going to make an acid solution, you're also not going to make neutral. You have no effect on pH. If you are insoluble, you have no effect on pH. And that's really, really important. You need to know that one. So we're going to recap this content today. So we're looking at the sources of acids and alkalis. And firstly, we're looking at what an oxide is. And an oxide is any element that's been reacted with oxygen to produce a compound. Then we looked at non-metal oxides. Non-metal oxides, things like carbon, nitrogen and sulfur, things from the right-hand side of the periodic table, they produce gases, things like carbon dioxide, sulfur dioxide, nitrogen oxide and dioxide. These gases that dissolve to produce acids, which can cause acid rain. And we can stop acid rain by using less fossil fuels. Then we looked at alkalis, and we learned that that metal oxides are what produce alkalis, but only when they are soluble. And we learned how to use the data booklet in order to find out whether or not an oxide is soluble. Importantly, we learned that if a compound is insoluble, we can't say that it's alkali, we can't say that it's acid, and we can't say that it's neutral. All we can say is that it will have no effect on the pH of a solution. So that was sources of acids and alkalis. Thank you for listening.